If you are a student or a professional in the life sciences or healthcare, and you want to learn data science and machine learning, either to move into the field or to do your day-to-day work better, then this is the video where I'll talk about the learning path that you should follow. Hi everybody, this is Guru here, and welcome to my channel Guru's Musings. I talk about technology in health, specifically with the focus on India. I'll be talking about the learning path that you need to follow to learn data science and machine learning, specifically for life science folks. And therefore, this would be different as compared to, for example, a person from the engineering background, while the focus for us as experts in the life sciences is to generate insight more close towards where we can deliver value, which means deliver value for our patients and other people in our health ecosystem. Before I get into it, just giving you a warning that once you go through the list, you might get a little bit overwhelmed. You shouldn't. This should be taken in a step by step manner, and you don't need to complete the entire journey. It all depends on what you want to achieve, what your interest is, and what your aptitude is. And the good thing about learn data science and machine learning is every step of the way, you learn, you gain superpowers. And with those superpowers, you'll be able to immediately show a lot of value, benefits, and power. So, how do you start this journey? And before I get into this, let me quickly say that I will be talking about the theory as well for each of these aspects of the learning that you need to do, which means a lot of these may have certain prerequisites that you may need to learn, for example, in mathematics and statistics. But my recommendation would be that don't wait till you learn those prerequisites to get started. This should run parallelly. In fact, what I would suggest is you start coding, for example, those models and statistics which I'll talk upon. And then when you need to interpret them, then you go back and try to learn the prerequisites. Now, coming to the journey, where do you start? The first step would be in gaining a lot of literacy around data, for which I would recommend the tools R or Python. Personally, I would recommend you to learn R, which is much more easier in my opinion, and you can get a lot of work done very quickly with little bit of coding. So what should you focus on? Get some data, download R, and just start working on it. Do some data manipulation, do some visualization, right? So I'll be talking about the details of how you can get started and what you need to do in R later on, another separate video. But for now, let me say that what is the superpower that you gain by becoming comfortable with R? Couple of things. One is you will be able to show a lot of insights with tables, figures, and other statistics. And the second would be in showing insight through beautiful visualizations. Again, R is very capable in that manner. Are there any prerequisites? There are absolutely no prerequisites. Anybody can get started. The only thing that you need to have is the curiosity and the perseverance. And it is just like learning another language, right? So if you want to learn a new language, I need to just be curious, and I need to be perseverant, right? Similarly, if you need to learn R, these are the only two things that you need to do. You should be perseverant and curious. Now we'll go to the next step in the journey. And if you stop here as well, you would have still gained a lot of skills and superpower. Now going to the second in our learning journey, that would be statistics. And when I mean statistics, I'm talking about the entire range of what you can achieve with statistics, starting from a lot of the measures such as mean, median, mode, then measures of our dispersion like standard deviation, interquartile range. Then when I talk about statistics, obviously probability also comes into the scene. So you would need to learn probability distributions, conditional probability, and so on. But what is the superpower that you gain? Primarily, it would be hypothesis testing. So which means you can compare two or more groups and come to a conclusion whether they are statistically significant or not. What are the prerequisites? Yes, you would need to learn a bit of statistics, a bit of probability as well. But don't wait till you complete the learning of the prerequisites. You just get on with it. And how do you actually apply these various statistical methods? You can do it in R. R has got all the capabilities to pretty much do any of the statistical methods. So go ahead, and once you become comfortable with R, you can apply these statistical methods in hypothesis testing, and then of course go back and learn a little bit of the statistics and probability theory. Now, which is the next aspect that you need to learn? And that would be, I would say, now we're going into the core modeling aspect. And there, first, I would suggest that we learn linear models, models such as linear regression and logistic regression. So for this, the prerequisites would be what I said earlier. That is, you need to have an understanding of statistics, probability, in addition, a field in mathematics known as linear algebra. And linear algebra is very important cross machine learning. What is linear algebra? You're actually learning approaches to handle collections of data in terms of vectors, which are single dimensional, matrices, which are two dimensional, and then higher dimensional as well. So, how to operate on them? What are some of their properties? Is what you learn in linear algebra. I would say that it is very important that you eventually learn a fair bit of linear algebra if you are interested in going deep into machine learning. So I talked about linear models. What is the superpower that you gain by learning linear models like linear regression, logistic regression? One is you're able to predict, right? So you develop a model and you use that model to make certain predictions. The second would be you can quantify the relationship between two variables, between the input variable and the outcome variable in quantitative terms. The next layer, the fourth layer, would be core machine learning, or you can say traditional machine learning, considering there are, if you look at what we are seeing currently now with regards to deep learning and then, of course, generative AI. So there are a lot of techniques in traditional machine learning toolkit. For example, you have tree-based models, you have methods such as support vector machines, you have bagging and boosting machines, you have methods like k nearest neighbors, which don't make any assumption around the data. What is the superpower that you get? Really good prediction, the ability to make predictions. So you develop a model which is much more accurate. And of course, there are issues around that. We'll not talk about that right now in this video, but it'll give you the superpower to make predictions. If you reach this point, you've already attained, I would say, a lot of skills that very few people have. And you'd be able to use those methods and techniques to generate a lot of insights on healthcare data, right? And that combination is really, really powerful. Okay. All right. Now, continuing in our learning journey, the next layer or the fifth layer would be deep learning. So in deep learning, you're dealing, the method primarily used are neural networks. But again, neural networks, there are multiple different kinds of neural networks. So deep learning is a very powerful technique. It can give you really good accuracy, but the problem is it is kind of a black box. You cannot actually look internally and see and interpret what's happening inside the model, which means you cannot quantify the relationship between the outcome and the inputs. So deep learning especially gives you a lot of power to handle unstructured data like free text and images, and of course other modalities like voice and videos as well. So these unstructured data, deep learning can work on those to, either make predictions or automate tasks. So if you learn up to deep learning, I think there is very less that you can't do. And again, the focus would be on generating insights for our people, which is people who are suffering, like our patients, or helping our doctors or researchers and so on. And finally, the sixth layer, which has come up recently, is around generative AI. So there are two aspects that you can learn in generative AI. One is the more engineering or the technical aspect, where you want to, tinker with the properties of these models. Now, the models that we're talking about are really huge. And that's why they call it as large language models. But that is not what I would recommend. This is not something that we should focus our effort on. I think we can deliver more value if we focus our effort on prompt engineering. So large language models have got a lot of power. If we need a certain behavior, then we should be able to appropriately communicate with it. And there are a lot of techniques that have come up recently in terms of how to best extract properties from these models. And that is the entire field of prompt engineering. I think our effort should be on prompt. We already have a lot of very effective large language models. If we are able to do proper prompt engineering, we would be able to, make the model behave the way we want to do, and that can generate a lot of value. Now, that sort of covers at a high level all the different aspects that we need to cover as part of our journey in machine learning. The way I called out this, it appears that this is kind of a sequential learning process. It is definitely not. In fact, in my own personal experience, I stumbled along the way. I first was interested in statistics, and that led me to the world of R. I learned R, and then I realized that there are these additional machine learning modeling techniques. I learned about that. And then a lot of back and forth I went into, and then much, much later on, I realized that I can learn deep learning as well. And then finally, what you're seeing is generative AI. So, my recommendation to you is don't think of this as a sequential kind of a learning journey. Just get started. Learn everything step by step. And then you will be able to figure out at each point in your journey what is it that looks appealing to you. And then you can, learn those. In fact, you can jump across this journey as well. And let's say you become comfortable with R, you can straight away jump and maybe learn deep learning as well. Focus, however, on delivering value, generating insights in the life sciences. Focus your effort around the interface between these techniques and our domain. Okay. So I would like to end this video now. What I would just like to say is don't think too much. Just begin your journey with R. In my next video, I'll talk about how we can exactly begin with R. There are a lot of tutorials anyway available. Feel free to join any of these courses. But anyway, I will share some of my thoughts on how we can quickly get started. Thank you and have a good day.